value at the point is 16. So that is the y-coordinate of the point that you are trying to find the tangent line to.
Okay.
So there's our point, right? We have our point now.
Oh wait. Well. Okay. 2.
All right, what else do we need to write the equation of any line? Say again? Slope. Okay, it's a tangent line, so its slope is?
That.
Nope, that's the curve itself. How do we find the slope of the tangent line?
Right over run. I guess. I don't remember.
Tangent line is the limit of the secant lines.
Oh yes.
So I said the word limit.
Mm-hmm.
Yes. So,
I'll write down that.
and it's going to have delta x in it somewhere. So see if you can pull that formula out.
Is it? Right?
Yep.
And then this is just x.
Close.
And this is.
Help her out, Bryce. What needs to be adjusted there? Tiny little adjustment.
There's only delta x in the denominator.
Right, because remember delta,
Oh, yeah.
the denominator, we would actually have x plus delta x minus x. So the x's go away. We're left with just delta x. And what is it that's approaching 0? Is it x or something similar to x?
I'm going to guess the second.
Mm-hmm.
I don't know what.
Okay, it's delta x that goes to 0. 'Cause
Oh,
what's
yes.
happening is delta x represents how far away we've moved to make our secant line, and we let it get smaller and smaller and smaller so that we eventually get a tangent line. Okay, so the thing on the right without the limit is the slope of any secant line connecting x f of x to something close to it, but greater than 0. And then we go to 0 and get our tangent line. All right, so now it's just down to algebra at this point. Okay, so what is your x that you're going to put in there?
2.
Yes.
Okay. Can I just dispense with the x, or do I need?
You can if you, yes.
And delta x. I leave it as delta x.
Yes. Okay, but hold on, because you have to remember that this is f of that. Not just x plus delta x, but rather f of it. So imagine taking your 2 plus delta x and plugging it into your f.
Oh, okay.
There you go.
Um.
And then it will be f of 2 as well. Okay. Let me scroll you down a little bit. Thank you. Okay.
Wait. So it was 32 over x.
Right,
So I plug in 2 plus delta x into 32 over x.
that's right.
So that's.
You're not going to be able to simplify that right off the bat. Perfect.
And this is 16.
Mm-hmm. Okay. So this is Bryce is the only one who's done these problems so far.
Yeah.
He's gotten all of our common denominator problems. Now it's on you.
Okay. I use 16 times 2 times 2 plus x.
Perfect. Fabulous. 16 times 2 is 32,
Oh, yeah.
which works out nicely for you because then your 32s go away eventually.
I'm not paying attention right.
Okay, so you have a 16 over 16 delta x, good?
Okay.
Okay. Do you want me to scroll down or do you want to go to the right?
Just go down.
Got it.
Keep it linear.
Okay, before you write that, alright, so now think about what dividing by delta x is equivalent to.
Divided by 0?
If we were to plug in, yes, which we don't want to do, but in general, dividing by a number is the same as multiplying by what?
It's reciprocal.
Good, so I want you to rewrite it that way because that's going to allow some cancellation to occur. Good. Do you see the cancellation that occurs?
Like that?
Yes.
So it's gonna be 16.
Right. Now, letting delta x just be equal to 0 there causes us no issues, right? We only have a problem with that term if we're at negative 2, but that's far enough away from 0 that we don't care. So now we've simplified enough that we get to just substitute.
That for 0?
Yep.
That's just 8.
Okay, now, you just went through all of these calculations and got this magical number 8. Do you recall what that 8 represents?
The slope.
The slope of the tangent line. And we were at the point 2 comma 16. So now the last step is to actually write the equation of the line.
2 times 2? What am I doing?
You're going to need to go with
X.
the
Oh, I'm doing it wrong. I was doing the point, the
intercept.
Yeah.
Yes, which you can finagle it to work, but I think it's easier to use the other one.
point slope.
Yes.
I can't remember how to go from this to the.
Okay, y minus y1.
Oh, yes.
Does Ms. Rand not teach this way of doing it?
We've done it before. I'm
Okay.
just incredibly
Okay.
tired.
And I just have had lots of groups who much prefer the intercept form to this point slope form, and figure that's
Normally it's because Saxon math doesn't really teach.
you're doing calculating
Oh.
you need equals m times.
Okay, I'm serious. I'm completely out of it today.
Okay.
What am I? What
Alright,
am I
the
doing?
point slope form of a line is y minus y1 equals m times x minus x1. Right, and the plain old x and y are your variables, which need to stay in there. The x1 and y1 are the particular point that you're working with.
This is 16.
Yes.
It's plus 2 because it's minus 2 in the.
No, we were at x equals
Oh.
positive 2, so it's minus 2.
Sorry.
That's okay.
Which cancels these out.
Mm-hmm. Y equals 8x. Okay, so let's verify geometrically that, or graphically, not geometrically, that 32 divided by x and 8x, and we're looking at the point 2 comma 16, so let's set our window accordingly. We're going to be undefined at 0, so let's go from 0 to, I don't know, 20. Let's see how that does. Alright, so, whoa. oh no, I did zoom fit. There's our curve. That is not tangent at 2. And in fact, our slope should have come out negative, so I'm wondering... Aha! I found it. It is right here. Minus 16 times 2 is negative 32. Minus 16 times delta x is negative 16 delta x. Negative, negative, negative. So that's going to change things up here because that went right by me. Negative, positive. So this is going to be negative 8x plus 32. Because now I have a positive 16 here and I have to bring this other 16 over. Okay, so that's better. That's not what I want. And we can go back to the window that I originally said. Here's our graph. Here's 2 here, and now we do indeed see something better.
Yay!
Approximating a tangent line. Yes. Okay. So that was a good way to check our answer there because
Sounds test.
you were. That's good. Yes, I failed the test back here, but managed to redeem myself later on.